active server page, actually within the .NET framework, which is a Microsoft technology we are just adopting to reach the generation, the creation, the development, the implementation of dynamically designed web solutions. The context of being dynamic, actually, we introduced that it is a feature to enhance the interaction in between the user and the front-end applications or front-end solutions or front-end pages. So whenever the same interface or the same, let's say, page is used by everybody, but it displays to user number one whatever he needs, the user number two whatever he needs, and so on. It displays different views to different users according to their requests. As a very wonderful and great example of dynamic web solution is for example, I can give you the Google itself, the search engine, Google. So all of us, we use the Google. Actually, we can use this Google, all of us. For what? For searching documents or files or resources, whatever. Me in Google, I can search for example, healthy food. You can search for this course content, the ASP, what is it? The other one can search for ASP.NET and so on. So all of us, we can use the same Google interface, but for different search requests. And we will get different results in the same interface. This is a very good example of dynamic web application or web solution. There is an interaction that the system has to handle perfectly within the, let's say, the different users. Great. First definition, actually, we presented at that time also. We defined what is web application. Yes, and we given the example of the cloud applications. Actually, here we are tackling the context of application purposely, not only the fact of being dynamic. So the Google Docs is a very good example of application to be delivered over the web. Lena just came in. Okay. Also, we presented a list of advantages that web applications do present to us, and the fact of being dynamic, actually, and the fact they are actually delivered over the web. So there are advantages for that. Mainly, and not only that, you have to stick in your mind that the web applications, they are actually solutions, services to reach anywhere, anytime, using different physical devices. Whatever you are using, a mobile device or a laptop or a desk computer, or even a server dedicated PDA, personal digital assistant device, all of them, they can help you reach the solution or the service that you are trying to reach over the web. Physical devices, they all support. Mainly, if there is a restriction, it would be actually noticed, but mainly physical devices, since they give access to the web, since they can support web browsers, so they can help you to reach the sources. And beside of that, actually, those physical devices, they are actually to be helping you as user to use the resource without any worry. I might use that to think about the updates and the requested version of software to be having in your device to run the resource or the solution. No, you just have to access, that's it. Your physical device, you have to have it to help you access the resource. So you need the browser only. For example, to open the Google. Yes, you do not need to know what is the version of the Google interface or whatever. What is the programming language is used to implement this Google or whatever. No, you only need a software to help you to access. That's it. The matter of the constraints related to the service itself, it is much more stressful when compared to an on computer or or an on-premise solution. Yes, exactly. As per software actually needed, mainly we talk about a browser. Yes, since you have a browser, so you can reach the resources. Mainly, there are other, let's say, constraints that we need specific tools to access web solutions, but for the majority of the cases, and for a first view, you need a browser to run any web solution. Besides, and there is another advantage, and it is very actually important also, is that to buy actually and to use a service or a solution or soft solution or a soft application, you need to pay for the license. You need to pay for the use. For example, you want to install the Microsoft Office Word, an excellent PowerPoint, or the Microsoft Office pack. You have to pay for the license to get it installed in your computer, and then after you use it. But you install it and you may not use it. You are not going to use it for the 24 hours per day and 7 days a week and the full year. No, you are going to use, for example, half an hour a week. And the other time you are not using it, but you are paying for the license, even you are not using it. So you are paying money which you are not utilizing. You are wasting it. Thus, the online web solutions can help you to pay only as per use, as per your use. Means you are going to pay if you use. If you don't use, you are not going to pay. So you are only paying for your exact use. So you are saving money in this way. There is an advantage of saving money in this regard. Another context, which is the scalability. And this stands off here actually. The Microsoft Office Word, if you buy the license to run it, you are going to pay it for your computer only. Yet, if I give you this scenario, you are going to change and you're going to have it in another computer. Are you eligible to install it in another computer? No, completely no. Actually, for the license you paid for, actually in this example, you are going to pay it for one computer only. So there is no scalability. You have to buy another license to install it in another computer. For the web solutions, actually, there is another restriction. It's not only payment. But also the context of being accepted. If you, for example, you are going to buy it for what device, can you use it remotely? There is another problem here, the remote use. So the scalability is 100% adequate and feasible and implemented when talking about the web-based solutions. Before I continue, before I finish, actually, I'd like to give you just a few seconds to interact with me and to give me a small, let's say, conclusion to what I was explaining you now. Huda, what I was actually explaining now? Can you just give me a small conclusion? What was the speech I just given you? هدى الكلام موجه لك. So we continue. Still in the context of the definition of the web solutions, environments, and so on. The architecture designing a dynamic solution or dynamic web-based solution. Actually, we need different actors to play in the role. Actually, to play in the scene in order to finalize this architecture. We start with the front-end client, which is the web browser, as we said earlier. So simply, you need a browser to reach web application. There are other solutions, yes, but web browser can be enough. So the first actor is the web browser. The second actor is the server, where the solution is. So this is the browser that you, as a client, you are going to use. The server is where the solution or the application is. So we are going to open an application now. What it is? It is in a web server. It is somewhere in the internet. But where in the internet? In a web server that serves you whatever you need as an end user. The web application actually it is another layer, it is another actor that comes in between the client and the server that does different tasks, amongst of them to specify what is the application required, the exact application required, and so on. It is a filter, it is an interface that comes in between the client and the server. From the tasks to do is to specify, because the server does not have only one application, it has many applications and it serves many clients. So which application is required by which client? It might be actually the role of this application server, this layer here. Fourth layer or fourth actor is the storage or the device utilized or the software utilized to hold the data that the application uses to run. So in the sense of we have a web server that the application resides in, yeah, okay, inside of it or just a side of it, either inside or aside. There is a database server that stores, here we are taking the example of database, but it is a data store that has the data responsible for making the application run, no more, no less. This is the number 4. There is another actor. It is actually a logic actor, logical actor. It is logically viewed in the sense of they are a group of rules that they support the context of the way how the application run, how those actors interact within each other, how the users can reach the resources, when the users can reach the resource, what resources are available, what resources are hidden, and so on. We talk about rules, policies, politics. Any questions?
No, teacher.
Okay, great, great. So still we talk about the architecture only. The web application architecture, it's as per the definition we saw just right now, it is a context of an interaction of group of actors amongst each other. So we have actors that they interact in between each other, and this is the architecture. Still talking about the architecture only, it is a resource. It is a resource to be actually it is a resource, yeah, built in certain or given programming language or dedicated scripting language to be utilized over or reached over the web, and to be reached over the web using a client, and to be reached over the web using a client over a protocol. I repeat again. Still, what is an architecture of solution architecture? We are talking about a resource implemented with web technology like the HTML mainly, not only. There are so many technologies. We see that in the coming future. Yes, those technologies, they are enhancing a solution to be reached remotely using the web or over the web using a client, the browser, and over the web using a client controlled by a protocol, group of rules. Resource remotely reached using a client controlled by a group of rules. Easy to understand and easy to memorize also. The same architecture is seen here in a graphical view. Just one term I'm going to introduce to you, the context of the tier. The tier. Earlier, earlier when we discussed that the architecture is made up of those layers, sorry, or those layers or those actors here, what does it mean? It means you are having at the end of the day, we have a client, you, me, he, she, and so on. We have a server that gives that serves clients their requests, In between, we have interfaces, layers. Each has its role. So we are talking about the tray only, tier only. Sorry, tier. So tier number, there is no number to fix here. We are not talking about standardized number of tiers. No, we are talking about an intermediary element that comes in between the client and the server. We might have only one. We might have zero. We might have n tiers. But what is it here? It is an interface, interface, interface that has a role to do, and it has to be available in between whom? The client and the server. This is it here. In this example here, we are seeing 5 tiers. It is not standardized architecture, but this is only for understanding and explanation purposes only. The web browser is one of the tiers. Web application, it is one of the tiers. Database engine or database server, it is one of the tiers, and so on. So whenever we have a filter or have a layer that comes in between, this is it is a persistent and insistency here. It has to be in between the client and the server, so it can be considered as a tier. The same view here seen actually in a more understandable, let's say, layer. We have the client, yes, and we have actually the technology that enhances the resource to be reached over the web, yes, and to deliver you the exact, those technologies to deliver you the exact actually required serves. We have a web server, we have application server, we have actually the group of rules and protocols to, and the rules to run your request and to run the responses from the server. And we have the data server, actually the store server, which is in this example the database server at the end, at the total back end. So this is another architecture, this is another view which we see actually an architecture, a web solution architecture. Web solutions actually they are numerous. Web solutions they are numerous. We talked about actually earlier we talked about the search engine. Yeah, this is a good example, but also they are not only the search engines to be considered as web solutions here. These long list as per title of example only to consider them. You can reach them actually all of them to be utilized over clients over the web. Let me just explain one or two of them. Yeah, reservation. Let's take the first one with the reservation system. It is a very good example to consider. Booking a ticket, booking an appointment, booking an event, or whatever. This is actually a good example to be considered as an online and a dynamic web-based solution. Why? Because we can reserve for the use of the same system. We can reserve different number of tickets. We can reserve different dates and different events at the same time using the same interface. So whatever. They are only a title of example to enlist examples of web-based solutions. Still in the architecture only, but here actually we are displaying it in a different view. Earlier we talked about the actors, and then after the interaction between the actors, and then after the context of the, let's say, the tiers and layers. Here we are seeing the architecture from another view. We are having two parties specifically, the hardware part, the software part, and the interaction between both can give you the architecture, the context of the architecture, what is architecture. So using a different view, a different actually explanation, we can again define what is a dynamic web application or whatever web-based solution architecture. It's an interaction between a hardware and a software to deliver a service, no more, no less. Regarding the software, we have to have the data storage. Yes, absolutely. We have to have the rules that govern the 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 service delivery, no more, no less. And then after the interaction actually, when we said that the Google is one of the good examples, of the dynamic solutions. Why? Because it gives us the chance to ask different requests using the same interface, and we get different results, different responses. So there is a control to be happening. It is the interaction logic or interactive logic. There is a group of rules that has to define, that is a group of rules that have to govern the interactivity in between the user, the client, and the server. Any questions, please, before I continue? Any questions?
No, Mr. Complete.
Okay, okay. Let's have a view about some technical presentations, group of technical terminologies that would facilitate our understanding to the context of dynamically designed solutions. The first terminology I'm going to define it to you, which is the loosely coupled. And this is one of the features that web solutions do present. Actually, when we compare any web-based solution to a non-computer solution, there are differences, absolutely. One of the very famous differences is the loosely coupled, or the web applications, they are designed to be loosely coupled. And the context to make us understand what does mean loosely coupled, to lose. You have to memorize like that. So lose means there is something to be forgotten or to be lost in this sense. All the web solutions or the HTTP solutions or HTTP driven applications, they are stateless in the sense of every request you pass to the service provider or the server would be actually generated again if you request it again. What does it mean? I'm going to search now. Now, immediately, I'm going to, for example, open the Google and search for the definition of what does it mean .NET. .NET, what does it mean? So I open the Google or open the Bing or any search engine and I type .NET. Okay, I will get a list of definitions and resources. Great. Okay, after 5 minutes or after half an hour, I want to search again for the same definitions, for the same list, and I'm going to use a different resource. Will I find them saved? No. I have to search it again. I have to open the Google again or the Bing again, and I have to type .NET again, and I will have to search. I will get another list of definitions. Why I can't find the same list I searched earlier? Because the property of the client and the architecture we are working with is loosely coupled. It is stateless. The browsers do not save states of applications or statuses of applications. In the sense of what you searched, if you close, it has been vanished. It would be lost. It is not to be saved in your computer. It is only to display. Once you leave it, everything has been emptied from the memory. Loosely coupled. So this is a property related to the web-based driven applications, which is not actually the case when we talk about on computer solutions. On the Microsoft Word, if you display something, it is there. If you just press Ctrl S or save it somehow, it would be actually saved in your computer. You'll find it later on. It is available in your computer somehow, or somewhere. But web-based solutions, no, not the case. Loosely coupled. So exactly what I was explaining right now, it is here actually. A user sends a request, the browser serves the request by displaying the response from the server, and then after actually the content, once it has been displayed and loaded to the web browser, it will be available only until the browser is left. So once you leave the browser, everything is going to be vanished from the memory. Full stop, loosely coupled, remember that. From the other actually terminology that they also represent the context of challenge when developing or designing solutions, web solutions, is the user experience or the API that to be displayed to the end users. What does it mean? It means actually the applications can deliver services, but very complex services to the end user. What does it mean? It means actually the user cannot understand what is the service or how to use the service and so on. So the user experience or the user actually interaction uh, with the service through the client through the web browser is one of the challenges, because we can design the same service but differently in a very easy way. The user can understand how to use and go step by step amongst the use of the service, or can find it very difficult and complex, cannot understand how to use it or how to actually use it simply. So this is said the user experience, and the user experience is seen when interacting with the APIs, the front end solutions, whatever the hardware you are using, smart device, an desk computer, a laptop, whatever the device you use. So the user experience is related to the API to be displayed. So through the client, through the web browser, the user interface is a question of helping either to easily understand how the service run and to use it, or is a question to be actually, it has to be ameliorated if in the case of complex and so on. So because of this only, we may talk about actually betterment, and we may talk about actually development that is better than the other. So a better development can lead to a better user experience. So in this regard, we can talk, define the user experience. This is another consequence. This is a consequence of uh, the effect of the user experience. Yeah, and in consequence, and in the end, actually, users can easily reach the resource, can utilize the resource easily without any um, difficulty, and thus they would be actually loyal to the service provider. They will not go and search for another service provider, because online do not expect to find a unique or a one simple user provider or service provider. No, there are hundreds and hundreds of service providers from the same category. Thus, to gain the users and let them be loyal to you as a service provider, you have to give them a good user experience, an easy service, let's say, reaching. They can reach the service without any pain, to make them be loyal to you as a service provider. Again, we keep going on, and we define what is scalability. We say that it is actually, it's a context of helping the users, as many as they are, to reach the service and get the service without pain. Yes, it would. This is a feature that puts the server in a situation to serve more and more users whenever they are requesting the service without any interruption, because serving 1,000 users at the same time is not the same thing when serving 100,000 users at the same time. It's not the same thing. 1,000 is much more smaller when compared to 100,000 users. What does it mean? I don't care. You may say, as a student, you may say, okay, what is the problem? 100,000 users or 1,000? No, there is a big problem. The problem is that there is a technical group of technical features that have to be available in order to serve this huge number of requests and responses at the same time. We need a bandwidth, we need a processing unit, and so on, actually whatever, that they have to serve all of those users at the same time. Thus, the scalability is one of the features that the servers or the service provider has to tackle when delivering a service over a server. And this is a consequence. This is a cause of a consequence to lead to describe the performance of a web solution, of a designed web solution. Well, here actually we may talk about the dynamic web solutions only, but even for static, non-dynamic solutions, also the performance is one of the questions. Is it well performed or not? Does it perform well or not? Still talking about the challenges only. When delivering or when generating a dynamic solution over the web, is there any specific technology to use? The answer here actually it is a little bit complex, but usually it would be falling onto a no. There is no one specific technology to deliver or to generate a service. We may create the same solution using different technologies. Technologies we talk about the programming languages. So so the recognition of the technologies to use to deliver actually dynamic solutions, dynamic actually applications is one of the constraints because we may generate a web solution using HTML only. If you know HTML, okay, you can generate an application, a web application. But is it dynamic? No, I don't think so because the HTML does not enhance the dynamicity, cannot enhance interaction or user experience within the interfaces. So this is a knowledge that you as a developer has to know. So you have to recognize the technology is enhancing the features or to actually provide or just help you implement whatever feature or service you are willing to implement. Technologies here we talk about programming languages or the tools to use. From the other challenges is the context of the security and the secure service delivery. Security to secure the user's requests and to secure the user's responses or the responses sent to users. So this is another challenge that the developers has to tackle. For example, when we talk about payment only, it has to be 100% guaranteed that the user, when he pays 1 real, he has to pay only 1 real, not more. His credentials, credit cards, and whatever he's using as a tool to pay, they have to be saved and isolated from external parties. So this is another concern of to tackle when developing a web solution. The context of security also. Any questions, please?
No question. No,
Okay,
no, Mr.
okay, okay. Let's have a small look at the technology we are following as per our book. As per our book, actually, we are going to design dynamic applications and solutions using the ASP.NET technology. ASP stands for Active Server Page. .NET actually it's another technology that delivers group of tools and list of tools that Microsoft is given to developers to use ready-made. It is a technology that enhance functionalities preset, pre-made, that you just use as a developer only. Drag and drop, copy paste, things like that. You do not need to write codes and so on. .NET. It is a framework. It is a platform over which you may generate your specific ASP solutions. It is a Microsoft only. We cannot use this framework for different purposes, but the Microsoft technologies. Specifically, we talk about the ASP. ASP is also a Microsoft ASP.NET is a Microsoft product that operates in a very coherent interaction to deliver web solutions, web-based solutions. This is a history first release, and this is actually a history of divergence and the description of divergence up to the date where the book has been written. Not today, but up to the where the book has been written is 4.6 actually, the latest version at that time. Then actually, along with the ASP.NET, we may enhance other scripting languages to run with, means to add interaction and interactivity, the dynamicity being dynamic. There are other scripting languages to use with the ASP.NET technology. As per our book, we're going to use the C Sharp. But there are others also, the VB, VB.NET, the J Sharp, and so on. They are all capable to run with the ASP.NET solutions. For what purpose? Why I have to use other scripting languages? To add the interaction, to add the dynamicity fact, to control, to add effects. So they have other tasks to do that the ASP.NET does not have this capability. Remember, from the challenges we talked about, knowledge. So you have to know what technology to use in order to deliver the service, the required service, or the that what service you are willing to deliver. So ASP.NET in so many cases is not capable to do all the tasks. You have to use other scripting languages to enhance or to finalize your serves or your dynamic serves. In our context here, as per our book, we're using the C Sharp. Active Server Page.NET. Network enabled technologies. They are actually Microsoft products only. Differences between ASP.NET and simply ASP. They're completely different. They're completely different. ASP can run on a simple text editor and can be actually written over a simple text editor and saved as an ASP page and hosted over a web server. Yet ASP.NET has to run over a .NET IDE integrated development interface like the Visual Studio specifically, and has to present the .NET functions like the tools. We talk about the tools, specific tools to use, the labels, the text boxes, the whatever, grid views, the tables, whatever the tools they are. The list of the tools available inside the Visual Studio is a very good example of the .NET. So ASP.NET is completely different than the ASP. ASP is ASP, yes, but the ASP.NET, no. It is a scripting language to run on top of a specific platform to use pre-made and preset tools or enhanced tools, let's say. To choose in between this or that, actually, you have to, as per we discussed earlier, the context of the knowledge. You have to know what do you need or what the service in question to implement needs. Then after you'll only have the chance to choose this or that. But as per our context here, we're going to use the ASP.NET and the C Sharp to enhance all the solutions we are going to see as per our learning courses. Yet they are 100% actually powerful and they will actually help us develop so many applications. And I may say all the applications you may think of. Yet you may say, why so there are other scripting languages, not only C Sharp? Because the C Sharp needs specific environment to run in. Thus, you may use this C Sharp. Otherwise, if you do not need this C Sharp, you may talk about others. If you need other specificities, and so on. So, based on your needs, you choose which technology to, to use in order to enhance your service. If you hear your name, please say yes. I'm going to take the attendance right away.